Okay, so we had the first example in the last video, so this is going to be example 2. So proofs involving series. So we're still on type 1, but we're going to do a second example because they all look slightly different. So the one we had last time was a little bit different in that you had 4n here and you 2 brackets, whereas this time we've got they're not multiples of 4, so we had 8 plus 12 plus dot dot dot, whereas now we've got 1 plus 2. So we've got the addition of all the natural numbers, and we've got a fraction here, n over 2 with a bracket. So it's slightly different to the last question, but it's still involving series, and why we know it's series is because of the plus. Okay, so if there was no plus, it wouldn't be a series, it would be something different. So if we had a minus, then we wouldn't have a series. If it was 2 numbers together, it probably would be a series. And usually in the other two choices, like the divisibility and the inequality. So divisibility, they will say divisibility, and inequality, you will have an inequality sign. So you will notice the difference between those 3. It'll be very clear. So that wouldn't be something to worry. If that's something that you were kind of worrying about, I wouldn't worry about that part at all. So it'll be very clear which of the 3 that they're asking you about. Okay. So we're going to get going. We're going to do the exact same thing we did the last time. Sorry for the slantedness, just trying to write across is actually quite hard. So I'm going to slant it a tiny bit and then try and move it back. So what I'm going to do is to prove. Okay. And again, we're going proposition of n is, and we're just writing this out again. Okay. So 1 plus 2 plus 3 plus all the numbers to n, being our last natural number because of the big N there, equals n divided by 2 bracket n plus 1 for all n element of natural numbers. Okay, so that's our to prove, and then we want to actually do the proof. Okay. So that's our to prove. We're doing our proof, and we're going with step 1. Just going to label this out again just so that we have it. You don't have to write 1, 2, 3, but if you want to make it clear for the person marking it, it's just not easier to mark it when it's broken into your 1, 2, and 3 sections. Okay. So 1, we want to show that the proposition of 1 is true. Or what we said before is the proposition is true for n equals 1. Okay, and like the last time, sorry, now I'm just going to get a green pen. We're going to get the last part here and all of this and fill in n is equal to 1 and see what happens. So we've got 1 here on the left, so n is 1. Equals, and we'll fill in 1, so a half, bracket 1 plus 1, 1 is equal to a half times 2, 1 is equal to a half by 2, 2 over 2, and 2 over 2 gives us 1. So we're happy that the left hand side equals the right hand side, so we know that P1 is true, or the proposition of 1 is true. Okay, that's never going to change. That actually will apply for all 3 methods. Sorry, not methods, all 3, I suppose, types. So this never changes, which is great. So you can always do step 1 no matter what. So we'll go to step 2 now. I'll just move this up a tiny bit. So 2 then is our assumption. Assume that proposition K or PK is true, or the proposition is true for n equals k. So we'll have our series, and wherever we see n, we're putting k. So proposition K, 1 plus 2 plus 3 plus all the way up to plus k equals k over 2 bracket k plus 1. Okay, and then we have our statement, so we'll say is assumed true. So we're assuming that's true, and we're going to go into 3 then. So we've made our assumption, and now we're going to have to prove that using our k plus 1. So prove proposition of k plus 1 is true. Or that the proposition, so you don't have to keep writing out this bit, it's either writing it like p bracket k plus 1 or saying the proposition is true for n is k plus 1. So it doesn't matter which one you write as long as you write one of them. So the proposition is true for n is k plus 1 given n is k is true as well. Okay, so prove that the proposition of k plus 1 is true, or that the proposition is true for n is k plus 1 given. So again, this part's really important to have in your statement. Okay, so again, wherever we see the n up the top, here and here and here, we're going to put in k plus 1. And again, like the last time, this plus 1 here is additional to the k plus 1 part. Okay, so just move this up again. Okay, so proposition of k plus 1 is 1 plus 2 plus 3 plus dot 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 dot. We put in the k from earlier and we're adding on k plus 1. So plus k, the next number is k plus 1, because if 1 is k, k plus 1 is 2. Because, so if k is equal to 1, then k plus 1 is 1 plus 1, which is 2. So it's the next number. So if we've plus k plus 1 is the next number after it, like 2 is after 1, equals, and we're filling in k plus 1 over 2, bracket, k plus 1, and again, we'll add that 1 in, and then circle this one, because it's the one that's going there. Close our bracket. Okay, and then we're just going to tidy that up. So I'm going to move it down, I'm going to skip this bit and just move down here. This way. Okay, so proposition k plus 1, 1 plus 2 plus 3 plus dot 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 plus k plus bracket k plus 1 equals k plus 1 over 2 bracket k plus 2. Okay, and then we're going up to the assumption part, and again we have our green box, so we're taking 1 plus 2 plus 3 plus dot 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 plus k is exactly the same as 1 plus 2 plus 3 plus k. So everything before the bracket part in our third step. So there, that green piece and that green piece are exactly the same. And we're going to sub this piece in for our green box. Okay. So again, replace with right hand side of step 2. Okay. And you're not going to get marks for saying that, but it's just for you so that you know when you're practicing these questions and when you're doing it, you know, if you like looked at the window for a minute and you're like, geez, what am I supposed to do here? It's just to remind yourself as you're going along, that's what I need to do. Okay. Okay, so we're going to replace that then. We've got proposition k plus 1, and we're filling in k over 2 bracket k plus 1 plus the k plus 1 bracket equals k plus 1 over 2 bracket k plus 2. So when we multiply this out, they should equal to each other. Okay, so we'll move up this up to the top here so we can see it here, and we multiply out both sides. Okay, so proposition of k plus 1. Okay, so when we multiply this, remember this bracket is over, so this bracket here is over 1, and when we multiply our fractions, we're multiplying across. So this bracket's over 1, and we're multiplying our fractions across. Okay, so k times k plus 1 is on top. 2 times 1 then is over 2, plus this bracket, k plus 1, equals k plus 1 over 2 bracket k plus 2. Okay, and we'll just multiply out the top bit here, and then we'll see what we can do. Okay, so proposition of k plus 1, k by k is k squared, k by 1 plus k over 2 plus k plus 1 equals, so again here, this bracket is over 1, and we're going to multiply across. So k by k, k squared, plus 2k plus k plus 2, all over 2. So the problem now is that we've got one single fraction on the right, and we've got one single fraction and, well actually we have two single fractions, because technically this is over 1 here. So we've got two single fractions on the left, we've got one single fraction on the right. So we're going to change the left hand side, make it one single fraction instead of two single fractions, to make it look like the right hand side. Okay, so common denominator there is 2. Everything's over 2. So k squared plus k is our first numerator. 2 into 2 gives us 1. Plus k plus 1 is the second numerator. 1 into 2 gives us 2. Equals k squared, tidy up the middle, 3k plus 2 over 2. Okay, and then just tidy this up. So sorry, I forgot the pk part. And the pk plus 1 part here. Okay, k squared plus k, 2 by k, 2k plus 2 over 2 equals k squared plus 3k plus 2 over 2. And then tidy up this bit, proposition k plus 1, k squared plus 3k plus 2 over 2 equals k squared plus 3k plus 2 over 2. So they look exactly the same. We have the left hand side equals the right hand side, and we're saying that pk plus 1 is true, having assumed pk is true. Okay, and then step 4 then, which is our conclusion. For conclusion is just making sure we tidy everything up. Okay, so again, we're going from the start. Proposition 1 is true. We said that already at the start here. So we're just repeating this part. Proposition 1 is true. Then we're going to repeat 1 and 2 together. So just move this up a tiny bit. So we did P1 is true. We're now doing if proposition K is true, then pk plus 1 is true, which is 1 and 2. And then our final part, so by induction, and we go back to this bit, Pn. Okay, so proposition of n is true for all n element of n. And then that's our question done, and you move on to whatever the next part is, or you can look over it, but you should be fine. Okay.